Hi everyone, greetings of the day. Myself, K. Chandra, Assistant Professor, Department of Artificial Intelligence, School of Computers, MITS, Madanapalle. Welcome all. Today's topic is stack data structure using arrays. So stack is one of the linear data structures available, and we will be discussing about that in this session. There will be so many other data structures also available like arrays, linked lists, nonlinear data structures like trees, graphs, etc. There are so many other data structures available, of which one of the linear data structure is stack. So we will see how we can actually implement stacks using arrays. So before going to the stack data structure, let us look into what is a data structure. Data structure is a means of organizing the data effectively. What is the meaning of organizing the data? It has got so many aspects to look into. How you are arranging the data, how you are placing the data in the memory, how you are accessing the data, how you are performing the insertions of the data, removal, retrieval of the data, and so on. So if you are doing all these things effectively, then you can say that you are working with an effective data structure. So if you're trying to use some sort of data structure and get this job done effectively, then you are using the effective data structure. So choosing the right data structure for right application is very, very important. Every individual data structure has got its own merits and demerits, advantages and disadvantages as well. So we need to understand how a data structure actually can be applied depends on the application. So today we are learning about the stack data structure. So it has got its own wide area of applications which we shall be looking into sooner. So before going to the applications, first of all, let us learn what is a stack data structure, how it can be implemented using arrays. So stack is a linear data structure. So it is a linear data structure. And when we are trying to work with a stack data structure, we will be following the working principle, which is last in, first out, or first in, last out. Last in, first out, or first in, last out. So what does it mean? It means that this particular stack data structure works in a way that whenever you're trying to insert an item last, that will be the item that will be taken out first. Or whenever you're trying to insert an item first into the stack, then that will be the item that will be taken out last from the stack. So if this phenomenon works, then we can call that as a stack data structure phenomenon. Okay, so again, stack is a linear data structure and it follows last in, first out, which means that last element that was inserted into the stack will be the first element that will be taken out from the stack, or first element that was inserted into the stack will be the last element that will be taken out from the stack. So these are the this is the working principle of the stack that we should understand. And what are the various operations that we can perform on the stack? We can perform operations like insertions. So whenever we are using the regular operations like insertions or removals, we need to use the official names. What are the official names? Like for the insertion, we will be using the name push. For the removal, we will be using the name pop. So insertion means pushing an item into the stack. Removal from the stack means performing the pop operation. So pop operation means you're trying to remove some data item from the stack. So likewise, you need to understand these are the formal representation names, push and pop. for the insertions and removals. Okay, so let us quickly go to the operations, how we can actually implement stacks using arrays. So in this example, we have taken an array of size. Okay, so let us actually choose the an array. Let us give the name of the array as a stack, so which is of type integer. So I'm taking an int array, int stack of what is the maximum size I can choose. I can choose any size, but for our example, I'm taking actually the size as a 4. And if you observe here, the picture of the stack representation using array, I also provided the indexes here ranging from 0 to 3. -1 indicates, that is underneath the last below index position. It means that if you are going to -1 index position, it means that nothing is there. So that actually resembles your stack is empty. So we are going to perform operations of the stack only from one particular dedicated end, other end being closed. So if you observe here, this end is closed, right? And this end is open. So we are going to insert, or we are going to take out the data item from the stack only from this particular end. This end is closed. So we cannot perform any operation from this particular down end. So we can't work there. Only one end is available, and we are going to perform either insertion, which is push, or deletion, which is pop, from that particular above end, for which we can only perform on the topmost element position on the stack. So for which we need to maintain a reference to the topmost index position, for which what we require? We require a variable, a top. So what does a top suggest here? So top will be pointing to the index position. See, let us assume that there is a data item 10 and 20 in the stack. So it means that your highest index position where the data is available is 1, right? So there has to be some variable top which should point to the index 1. So that is the meaning of that. So we are going to maintain the topmost element in the stack with an index, which is pointing to an index, which is the topmost index position. For which what we require, we need to also have a reference variable, which is top, which keep track of the topmost index position where the data is available from the stack. So initially what we should do, we should make the top is equal to -1. So what does -1 indicates here? As you can see in the picture, if at least one element is there in the stack, for example, let us remove 20. If there exists only one element in the stack, then you can see that the index position, the top is pointing to is 0, right? If there is no element in the stack, what does it mean? Then definitely the top needs to be decremented further. It means that the top will be pointing to -1. So top is a variable which we will be using to keep track of the topmost position value in the array. So top is equal to -1 suggests that there is no element inside the array. It means that your stack is empty, because currently we are trying to work with the stacks using arrays. So your stack is currently empty. It means that there are no elements in the array. That's why we need to initialize the top with a -1 initially. Then later we will be performing incrementing or decrementing, whatever it is, based on what kind of operation you're trying to work with. Top should every time be incremented by 1 whenever you're trying to perform push operation, so that you can push the data into the updated top. Similarly, top should be decremented by 1 whenever you're performing the pop operation, suggesting that now the topmost element has been removed, so the next updated top is the decremented value. So that is how we are going to try to work with. Okay, so what are the various operations basically we can have a look into? Push operation in a stack, pop operation in a stack
which tells about how to perform insertion of the data into the stack, how to perform deletion of the data from the stack, and similarly, if you want to refer to the what is the current topmost existing data element in the given stack, then you can use the function called peek, P-E-E-K, peek function. So if you want to display all the elements from the stack, then also you can use the display function. You can write your own function, any can give any name, but I'm just suggesting the names which are actually we are regularly using. So push is a function for insertion, pop is a function for deletion, and peek function so that you can currently see what exactly the topmost index position pointing to. Yes, and display function. So now let us actually have a look into all the operations possible. Let us first of all focus on what is a push function. Push function. As I already told you, push function is meant for insertion. So what exactly we are trying to work here is, we need some data to be taken into the stack, right? It means that we will call the function like this: push of some int and some data. So this data needs to be inserted into the stack. Let us assume that the current data that I want to insert is 10. The data that I want to insert is 10. So what I want to do here, this data needs to be taken into the stack. So we need to write the function something like this, the operation push. So inside push function, we need to write some code so that the stack operations can be performed effectively. But before inserting the data element into the stack, there are certain conditions that we should look into. What are the conditions that we need to look into? First of all, let us analyze. Is it possible to push any data item when the stack is empty? Yes, because stack is empty, it means that lots of space is available inside the stack so that any data item that you can place in the stack now. Second thing is it possible if I want to place the data inside the stack when the stack is full? Is it possible? No, it is not possible. Why it is not possible? Because stack is already filled with all the data elements. Stack is full means what? Stack is filled with all the data elements. So you cannot insert a new data item further. It means that let us write the code, let us write some values here. For example, 10, 20, 30, 40. Yes. So if you see here, the topmost index position top currently now suggests pointing to is what? Not -1, 3. It means that top is pointing to the last index position. Yes. So last index position is 3, right? Because we have taken the size of the stack as 4. When the size of the stack is 4, what it means, your ranging of the indexing starts from 0 to some other value. So since it is 4, it should be 0 to 3. So your top should be pointing to the size -1. Since indexing starts from 0, so top is 3 now. If top points to 3, what does it mean? It means that all the elements in the stack are completely filled. You can't increment the top further because you have reached to the last index position. So under this condition, when the stack is full, we cannot perform new insertion. We cannot perform new insertion of the data item into the stack. We cannot perform the push operation. We cannot perform that. So we need to first of all check for that condition before applying the push functionality. So we need to be careful here. So what we should do, before inserting the new data item into the stack, you check for the condition. What is the condition? Whether the stack is fully filled or not. If it is filled, we cannot do any further activity. We should return from there simply. Otherwise, we can actually perform push operation. So what is the condition to be represented at the beginning here on top? If, so we know that if the top is pointing to the topmost position, then it means that stack is full, right? So if, how we can say that top is full, it is pointing to the last index position. So it should be always the size minus 1. If size is equal to 4, in our case, then it should be 3, right? Total 4 minus 1. So size is 4 in our case. So 4 minus 1, so which is 3, it is pointing to the last index position. So if your top is pointing to the last index position, what it means, your stack is full. So it means that we are printing here, like I'm simply specifying printf like a pf here. So printf overflow condition. So what does it mean? What is the meaning of overflow? Overflow means your stack is now completely filled. If you add something beyond that, it will become overflowing. Okay, so it is something like you can't insert a new data item into the stack now because already filled. So stack is currently going through the overflow. So if this condition is true, then what we can do? We can't do anything, right? Because it's already completely filled. The new data item, whatever you want to insert, it cannot be placed into the stack. So what we can do? So we can't do anything further. So we need to simply return from there. Okay, simply return. So this is the one block of code that you should verify for the stack fullness earlier. Okay, otherwise if this condition actually got failed, for example, then what we should do, we need to go to some else block of code. So else block of code should tell you what. So if stack is not full, it means that there is some space available inside the stack. So what you can do then? Let us assume the scenario that currently there are 2 elements in the stack. So top is pointing to the index position 1. As you can see that, is the stack full here? No, because top is not the last index position. Top is pointing to 1. It means that still spaces are available, right? So what we are going to do here in the picture of the array, the top, first of all, we need to increment the top index referencing to the one more above value. So top should become now 2. Then inside that particular array of top, we need to place the data, whatever we want to add. 30, 40, 50, whatever it is, 25, 16, whatever the data element that you choose. But before pushing the data item into the stack, your top should be incremented by 1 so that it goes to the exact appropriate index position. Then after that updation, now let us increment the top by 1. So top will now point to 2 so that inside that particular top, you can insert the new data item. So that is what we should represent in the else block here. So in the else block, what we will be trying to do, first of all, increment top by 1. So you need to perform top is equal to top plus 1. What does it tells you? You are updating the top to the one extra position, next position. So inside that updated top position, you can place the data. So how you can write the code for that? Inside the updated top position means what? So inside the stack of top. So we are already we have taken an array, right? In stack of 4. So in that array, so what we should mention? So inside the stack array, what is the updated top position that we have previously mentioned, that top is equal to top plus. So this top position will be representing here updated top position. So inside the updated stack top, what we should do, we should place the data item whatever we are receiving into the function. So that data item needs to be specified here, isn't it? So these 2 lines of a code suggests how to perform push operation. First, what we are trying to do, you're trying to increment the top by 1, and then in the updated top position, you are adding the data, you are inserting the data, you're placing the data into the topmost index position. If our data is 30, for example, then we are placing the data 30 into the updated stack top. It means that now 30 will be updated here, isn't it? So that is how your stack push function can be looked into. So as we have seen how the operation like insertion, which we refer as a push in a stack, has been actually looked into. And similarly, we shall look into how we can actually perform pop operation. So what is a pop operation here generally? Pop operation means we are going to remove something from the stack, some data element. Which element we can remove? We cannot remove every data element that we want to. It is not possible. We can only remove the topmost data element, because already I told you we are going to perform operations on the topmost available. What is the top indicates there? So the top is a variable which is pointing to the last index position, topmost index position. So upon that particular position only, we can perform any operation by manipulating that top. So if you want to remove also, you can't remove any data element. Rather, you need to actually decrement top by 1. That's the meaning of that. See, for example, in the existing scenario, the top is pointing to the location index 2. So what is the data element available at the index 2? It is 30. So if I want to remove 30, what should I do? So the top, after removal of 30, the top should not point to the index 2. Rather, it should decrement it by 1, right? So it should come to this particular area and it should point here. So what I should do, I should decrement top by 1. So top will become currently, the updated top will become 1. So this 30 will be removed. So that is the meaning of performing pop operation. So this 30, whatever we have removed, we can take out and we can store in some variable called x or y or whatever it is, and we can use it for further usage. So that is how you can actually try to work with. Okay, so let us first of all have some data, like as I already mentioned here, 30. 10, 20, 30 are the stack data elements. Now I want to perform pop operation. So similarly, how we have seen for the push function, let us also look into the pop function. Under what conditions we cannot perform pop operation? First of all, can we perform pop operation if the stack is completely filled? Yes. Why? Because the stack is completely filled. So data elements are available inside the stack, so we can remove them one by one. So pop operation we can directly apply when the stack is full. Fine, no problem at all. Can we perform the pop operation when the stack is empty? We cannot remove any data item from the stack if the stack is empty, right? Because there are no data items inside the stack. So we cannot remove any data item. So what does it mean? We cannot perform pop operation under the given condition that stack is empty. So there has to be minimum at least one data element to be placed inside the stack, then only we can retrieve it. Otherwise, we cannot do any retrieval. So what it means, first of all, we need to have an inspection condition. What is that? Whether the stack is empty or not. And how we know that stack is empty? Already we have seen in the beginning stage, we are initializing the top is equal to -1. We are initializing the top to -1. Top index position to -1 indicates what? It means that your stack doesn't contains any data elements. Yes or no? Top is equal to -1. So it means that your stack is currently empty. The same condition we will be representing here. Okay. So if top double equals to -1, what does it mean? It means that currently top is pointing to the index position -1. It means that there are no elements inside the stack. It means that the stack is empty. So you cannot perform any deletion. So you need to mention that here. Similarly, printf. So for this condition, we need to use the word underflow. So printf underflow. So stack is empty. I cannot remove anything from the stack. So if this condition is actually working, it is true, then what we can do? So we can, it's a basically like an error condition, right? Because you are trying to retrieve something from the stack even when stack is empty. So you should return abruptly then immediately. So you can provide something like this. Maybe immediate return. Yes. So if this condition is true, it means the stack is empty. So you need to return from there immediately based on the condition. If that condition is false, it means that there are certain data elements available inside the stack. Let us assume that 10 is there, 20 is there, 30 is there. Okay. Okay. Now, for example, 40 is also there. For example, your stack is completely filled. So then what we should do in the pop function here, we are having some data elements actually. So we need to perform pop operation. So again, we need to go to the else block. So else block does what? We need to see here. Currently top is pointing to index position 3 because all the data elements inside the stack has been filled. Now I want to decrement the top by 1 because I want to remove the topmost element position because I have called pop function, right? So this 40 will be removed. So let me tell you that the popped up element, the popped out element also can be saved in some particular variable. What is that? For example, let me take an integer variable. So int x, and I can store that the topmost position first of all. So stack of top. So I'm trying to retrieve that stack of top. So currently, whatever the topmost position value of the stack, take out that and store it in x. So I'm storing that x is equal to 40 here because that is the currently topmost index position value held by the top variable. Top variable and the value inside that variable actually. So x is equal to 40. Now what is going to happen after storing that x is equal to stack of top? So this x can be used for further reference, further usage purpose, whatever it is. If you want to use, you can use. If you don't want to use, it is fine, no problem. Now what we should do? Okay, the top we need to actually decrement because we don't want to work with the index value 40 here. We popped it out, so we need to immediately update the top to the next available index position, which is 2, for which what is required? Decrement top from 3 to 2. It means that it requires a decrement by 1 operation. So first what we should do, top is equal to, you should update the top, right? So top is equal to top minus 1. So you are decrementing the top by 1. So previously top is pointing at 3, now top is being pointed to 2, isn't it? And this x value, integer x, we have already mentioned on top. So this x will hold the previously popped out element, isn't it? So if you see here that x actually can be used anywhere. So whoever will call this function, let us return this particular x value to that function caller. So what we can do here, maybe we can return them this x. So this x is of type integer, so we need to specify the return type of the pop function as the integer. So that is how pop operation can be looked into. So in simpler terms, push can be performed only when stack is not empty, stack is not full. So we need to check for the condition whether the stack is full or not. If the stack is full, we can't do anything, just return. Otherwise, increment the top by 1 and add the data element in the updated top position. Pop operation can be performed only when the space is data is available inside the stack. If the no data, if stack is empty, then we cannot perform pop operation. So accordingly, the initial conditions are to be inspected first, then you need to apply the relevant operation possible. So these are about push functionality and pop functionality we have seen. Now let us look into the other functions also which are available. Let us first of all look into how to perform, how to actually currently find out what is the topmost element position. There is a function called peek. P-E-E-K, peek function. What does this function tells us? Peek function displays the topmost index position element. So we know that the topmost index position always being pointed to by the variable called top. So we can simply use stack of top print stack of top. That will be simply printing the topmost value inside the stack. But before going to print that, we need to have a condition. What's the condition? We can only print when there is some data, right? So when there will not be any data when the stack is empty. So if the stack is empty, you cannot print anything. You cannot actually display that. So you should check for the condition whether the stack is empty or not. If the stack is empty, you can't actually print the topmost data element. So for which we need to write a condition. What is the condition? If top double equals to -1, what it tells us? Your stack is empty, right? So for example, if the stack is empty, it should be pointing to the -1. So if top is equal to -1, we can't actually print. Okay. So we simply what we should do, return from there, or else what we should do, maybe you need to print the data. What is the data? Integer data, right? So %d comma stack of, as you know, peak operation means the topmost index position value we need to print. So stack of top. We need to print on the screen. So that is the meaning of peak functionality. It means that we need to actually display whatever the index position top pointing to the value, whatever the value it is. We need to display that on the screen. Okay, so simple function, just print the stack of top on the screen. But before that, check whether the stack is empty or not. If stack is empty, then we cannot do any activity, simply return. Otherwise, we need to print the stack of top. So see, currently, for example, let us assume that there are values 10, 20, 30 here. So what does top is holding to? Top is now currently index position 2. So stack of top 2 means 30. So 30 value will be printed on the screen. So that is the current top value, isn't it? So that is how the peak function works. So again, let us look into another functionality, display function. So what is the purpose of display function? We need to display the elements inside the stack available. So as you can see here in our scenario, currently the stack is completely filled and top is actually pointing to the last index position. So I just want to print all the data elements inside the stack. So I can choose any order. Yes, from top element to the bottom element I can display, or from bottom element to the top element also I can display. So first let us actually try to display the topmost from the top element to the bottom element inside the stack. Yes, so how it can be seen, like 40, then 30, then 20, then 10, isn't it? The topmost is 40, then 30, then 20, then 10. So this is the order I want to see the output. So in that case, what is required here? You need to traverse from the top to the last index position. Top is the topmost index position, and last index position is what? 0. So within that range, you need to traverse, for which we require a loop, right? So use a loop for int I is equal to top, because you are starting from the top index position, and I greater than or equals to 0. So until you reach 0, and I should be decremented every time, because you are actually trying to work from the top to bottom, right? So every time that I index here, I value should be decremented further at every time. And until you reach 0th position, that has to be your last position, isn't it? So I is equal to top, I greater than 0, greater than or equals to 0, and I minus minus. So as long as these conditions are satisfied, then what we should do, repeatedly we need to print the data. What is that data here? Printf %d, which is integer data, comma stack of I. So I will be initially top, then top here initially is 3 kada, so 3. So I is initially 3, then I will be 2, then I will become 1, then I will become 0, and there the loop stops. So all the data elements, first 40, then 30, then 20, then 10 will be printed on the screen. Similarly, you can also use another way to print the data. If you want to print in a reverse order like 10, 20, 30, 40 also possible. So how you can do that? The same for loop you manipulate. In what way? Previously what we are trying to do is from the top to 0. Now what we can do is from 0 to top. So for initially what we should do, int I is equal to 0 until you reach top, right? So I should be less than or equals to top. And here, since you're going from bottom to above top, there has to be incrementation. So you need to perform I plus plus. If you do this, so first what will be printed? What is the index position 0 holds value? That is 10, then 20, then 30, then 40. So that is how the data can be printed on the screen. So that is how you can work with the display function. Yes? Okay. So these are basically the functionalities available inside the stack as we have seen. What are the operations we have seen? Push operation, pop operation, peek operation, and display operation. And finally, let us look into the applications where we can actually apply the stack. So what are the various applications of the stack? As I already told you earlier, every individual data structure has got its own advantages and its own disadvantages, definitely. So it means that there will be a suitable area where we can apply the particular data structure. Also, there could be potentially might not be a suitable area to actually work with a data structure. So stack also can be used effectively in certain wide application areas, and in certain applications also we cannot use stack data structure. It has got its own importance to look into. So let us look into what are the areas actually we can work with. We can uh, apply the stack data structure concept. So the main thing is about the stack is actually the concept of stack is backtracking. It helps in a backtracking. What is the meaning of backtracking? It means that if sequentially you are jumping from one particular state to another state consecutively, so currently you are in a nth state. First, from the first state to second state to third state to fourth state, like that continuously you have been jumping on to, shifting on to. And currently, if you are if you are in nth state, then if you want to get into the previous state, which is n minus 1 state, yes, from that n minus 1 state to its previous state, which is n minus 2 state, then what is required here? The backtracking, right? So I'll tell you what exactly it is. Let us take a pictorial representation of a stack here. Currently, uh, you just want to, you're currently at the state, for example, represented A state, and from which you have been moved on to another state which we call as a B. Accordingly, I'm trying to update the data in the stack. Then C, then D. So the top of the stack is pointing to which state? That is currently active state, which is D. Now after D, you want to close it, you want to revert back from where you came from. So to that particular previous state, you want to go back. So you want to come here, backtrack here. Now how we can do this activity? Stack data structure is the ultimate best data structure you can go with, so that you can actually go back to the previous state. Simply what here, top currently points to D. Now decrement top by 1, which means that top will come here. So it means that now top is pointing the previous state position, right? So similarly, decrement top further, that will take you to B, its previous state. So simply by applying pop here, actually you are actually going to the all the previous states possible. So we can perform backtracking by applying pop functionality. So backtracking is one of the significant, very important application area, so that stack data structure can be effectively used for it to get the job done. So there are many uh, applications of stack which requires backtracking. In graph traversal, one of the graph traversal we call as a depth first search. Depth first search. We use the stack data structure to traverse in a given graph. So we will be using the concept of depth, which means height, and which requires backtracking in that particular application. So stack data structure should be used there. So as we have seen here, going from current state to the previous states can be effectively done by stack. So stack also can be used inside a for the kind of activities which are similar to, which are actually undo or redo activities as well. Because as you have seen that we can actually go from current state to the previous state. That is how the data structure actually works. Last in, first out, or first in, last out mechanism. So that actually enables to work with undo operations or redo operations effectively. So also it can be effectively used for function call management. As we all know, function call means you are actually, whenever any function call occurs, you are jumping from one particular location to the area where function has been defined. So for which to work that effectively, you require a stack data structure. So going to that function definition and again returning from that particular function definition to its own function caller, with the help of a stack data structure only, effectively you can do that. So for which stack is very important to work with. So function call management is one of the application area. And there are many more like that. Let us, how to actually conversion of infix to postfix. So expression representation infix to postfix conversion also requires stack data structure and evaluation of this expression. So stacks can be used for the evaluation of the expression. So postfix evaluation. So likewise, there are many applications areas of the stack. So these are quite a few which actually I am reflecting here, but one should understand that stack has got its own way of working. So it has got certain areas where it can be effectively used. And similarly, what we should focus on, it is not applicable everywhere. It is not applicable everywhere. Now, for example, if I want to work with a data structure which should work in such a way, whatever the data item that was inserted first should be the item that should be removed first. If that is the way I should work with, then I can't go by a stack data structure. So it has got its own importance. At the same time, it has got its own restrictions also. So one should understand that. Okay. So these are a few applications of stacks where we can implement, and there are many more, etc. So many applications available. So, but as it now, these are the applications that I can actually tell you about the stack where it can be applied further. It requires one's own exploration of looking into where actually stack can be applied in multiple areas. Okay, so what we have seen in this session is what is a stack, what kind of a data structure is stack, and we are implementing this particular stack using arrays. What are the operations we have performed? Before going to the operations, what is its working principle? LIFO, last in, first out, or first in, last out. What are the operations we performed here? Push operation, which is insertion, pop operation, which is deletion, peek operation, which actually displays the topmost index position value inside the stack, display function, which displays all the elements inside the stack. Then we have seen the applications. What are the various areas actually the stack can be used in? So mainly backtracking. For backtracking wherever. So backtracking means recursion, for example. If you're trying to work with the concept of recursion, which is very important concept. Yes, recursion requires backtracking, because you are jumping from the function call to its own function again. So you should revert back. So for that revert backing, you need to definitely use the stack data structure. So likewise, there are so many areas where stacks can be applied. So backtracking is its own scenario to look into. So wherever the backtracking is required, stack is preferred there. Okay. So we have seen few application areas as well. So that's it for today's session, and thank you for listening.